I use it like, I love it.
So, I mean, I'm projects and
Like the keyboard, like
unused for
yes, but okay, like it is sensitized with
Oh wow.
Word.
I mean, I took has email guys to finish the practical session.
Wow. What was the last slide? Remember?
It's called News Score. It's like,
Not having to use it.
and I'm using it, and then there's so many things. People have used it, like, people struggles. Take that, like, it would take me like half an hour to do one phrase. They could do it in 10 minutes.
You can do
I got a 6 one up now. The good one is. So let me hook you up to the monitor, make sure that you can see you. And then I'm going to put my computer up in class. Just so you can see, so then fall asleep.
it's gonna be on the second. And it's gonna
And can you pronounce the last name for me? Okay, I just want to make sure. Yeah. Okay. Screen over here. And then I will turn you around as well. Oops. I lost the connection.
Oh yeah, definitely.
You know, these tech schools, you think we have better technology to connect all these things.
It's a great place. I've been there. It's a nice place.
You're precariously sitting in a document camera right now.
All right.
So we'll get started in like 2 or 3 minutes.
Okay.
They come in. Where's everybody?
On their way, on their way.
So how many people are missing today? How many people are supposed to be missing?
Uh,
Usually just 4 or 5, right?
Yeah, generally 5 people are missing.
Okay.
Ashish, Rupak, Chris Laguna,
Leia.
Leah, and Chive.
Okay.
5 people. No, Chive is usually here.
He's usually here, yeah. He's right there.
Yeah.
You're in trouble. Make sure you see the principal at the school. No, we push 5, generally not here. And he says you're usually not here.
Ashish, Leah, Chris, Rupa.
And,
have last time.
and maybe,
Hua, right.
Let's go ahead and get started because.
All right.
So today we have Rebecca Fiebrink coming to us via Skype from London. She was once at Princeton, now at Goldsmiths University, and she does her work in human-computer interaction, human expression, and creativity. So I hope I got that right.
Yeah.
So we'll just get started, and we usually end class at 5 till, so 2:55 our time. And,
All right.
All right, thank you.
Great. Can you guys see my slide on the screen right now?
Yep.
Great. Can you see me too, or am I hidden?
Yes.
Yeah, we can see you.
All right. I'll try not to do anything embarrassing then. So thank you for having me. It's good to be here. I am going to talk through a lot of my research using machine learning to support creative work. Do feel free to interrupt if you have any questions. I'm hoping to, I have more material here than I need in order to talk for 55 minutes, so I've got stuff that if it's a nice starting point for a question, then we don't have to finish the slide deck. So I'll let you guys figure out how to interrupt me if you have a question. All right, with that, let me see if I can get started here. So I wanted to start out by showing you guys a couple videos of pieces that composers have made with the machine learning-based tools I'm going to talk about today. And this first video is a piece by a composer named Anne Hagee. And the controller that she's using for this piece, some of you may have seen this. It's a PlayStation golf game controller. And she made a really beautiful piece. You can watch the whole thing on Vimeo. But this piece starts out with a very specific set of motions that she had in mind. She wanted the beginning of this piece to have the performers moving in a way that's very much like the yoga sun salutation. And so she came to this with an idea of visually what she wanted in her head for the performers and what kind of sound palette she wanted to use, and use machine learning to build this. So I'll let you, maybe Timothy, you could play this first video.
Sure. Too many windows open. Tabs.
Yeah.
Here we go.
The second video I'm going to show you, I'll have Timothy show you, is a video of Letitia Tsunami, who hopefully you're familiar with her. If you're not, you should go look her up. This video is from her NIME 2014 keynote performance. And the instrument that she's playing is, it's got springs stretched across this wheel, and at the end of each spring is an audio pickup. And you're not going to hear the audio made by the springs themselves, but she's using these audio pickups as sensors to get information about how the springs are moving, and then she's applying machine learning to that and doing some stuff I'll talk about later in order to produce the sound that you hear. So go for it, Timothy.
Okay. Is there sound in this video?
There is. It might be a little bit quiet. If you might have to turn it up.
Let me restart it.
Okay.
I'm not hearing anything.
Mm.
My sound is up.
If you skip to about the middle of the video, do you get anything?
No.
It's very,
Oh, I hear.
it's very feeble. It's very faint.
Oh, there we go. Okay, let me try it again.
All right.
That wasn't the buzz. Okay?
All right. Great. So in the rest of my talk, or I guess the next part of my talk, I want to talk about the research that I did up until this point to make the software that you see being used in these two instruments. And then to kind of give you an idea of where I've taken that in the past couple of years based on the feedback that I've gotten from composers. I started out my graduate career as a music information retrieval researcher, and I was really interested in how you could use machine learning to do new types, more powerful types of music analysis, for instance. And then I got really interested in using machine learning to support these kinds of activities. Once I started a PhD at Princeton, I was working with composers who were building a lot of new instruments. And so that's really the starting point for this work. I'm not coming at this with a set of questions about what is machine learning good for in musical instrument building, but really I'm coming at this with a set of questions around, how can I make it easier to build musical interactions with sensors? And as most of you probably know, we're in a really lucky time period right now. We have all these sensors that you can use to make real-time musical interactions, from Kinect and Wiimote to Leap Motion to building custom systems with Arduino, or even using sensors built into your mobile phone. And this is just getting better, right? Sensors are getting cheaper, they're getting more easily available, easier to hook up to each other. And of course, this means that the set of musical instruments that we might make is getting bigger and bigger. And the way that I usually think about instrument design, usually I would break it into these three components. So first of all, you have to sense what the performer is doing. Then you have to interpret what that performer is doing. Say, all right, given that I see this sensor data coming in, what kind of response do I want to make? And with current tools, the sensing is pretty easy with these sensors that you see on screen. Producing the response, making sound, is pretty easy if you know how to program in Max or Ableton or something else. You can make sound, that's what you do. But this interpretation step of saying, given that this is the sensor data I see, what kind of sound do I want to make? This is often difficult or at least annoying, and it's that part that I focused on in using machine learning for musical instruments. And of course, the standard way of approaching this mapping is to write programming code. Right? You end up with a lot of nested if and else statements with heuristics that look for particular things happening in the signal. You end up doing a lot of signal processing, applying smoothing filters, extracting features, and then again, applying these sort of heuristics in programming. And you could get a fair ways with this. However, there's a lot of problems with it. It takes a long time. It's not very creatively engaging. And so in my work, I get rid of that and replace that with machine learning and with other things that might look like machine learning or optimization. So with that, let me talk about two very specific types of applications where this can be useful. These aren't the only two applications, but these are good starting points. One of them is to say, all right, I recognize categories that a person is doing. So if I do this in front of my camera, I may want the computer to recognize, well, that's a closed fist, therefore play this one musical loop. And when I do this other totally different thing, recognize it as this other category, play a different musical loop. And so if you've done machine learning before, you'll recognize this as classification. Another way of using machine learning, another way of enabling interactions when you're building an instrument, of course, is to say, well, I don't want it to just recognize categories of what I'm doing, but I want to continuously control things. So maybe I want to move my hand in front of the camera, and as I move my hand in this way, I've got these virtual sliders on the screen, maybe in my Max patch, and I want them to move in this particular way. And that's a problem. If we want to solve this with machine learning, we can approach this as a regression problem. So supervised learning is a set of, it's a family of machine learning algorithms that allow you to basically do this kind of problem. And I did email Gil, for instance, and get him to tell me a little bit about who you guys are, what you're doing. He said a lot of you have a fair amount of machine learning expertise. Some of you may not so much, and that's fine. Do feel free to ask any questions. I'm keeping this kind of high level, but I've got some slides later on that get into some of the interesting details. So if you're not familiar with supervised learning, this is basically what I'd like you to have in mind. The idea is that we have this model here, which is going to be our function. You can think this as our mapping function, which is capable of looking at what the performer is doing and then computing information that's going to allow us to make the appropriate sound. So that might be a label of what category we want to do, or it might be real value parameters that we want to use to control like a max patch. So usually we would write this model function by writing code. If we want to use supervised learning, instead we use a supervised learning algorithm. And this algorithm takes a training set. Each example in this training set is an example of a human action paired with the appropriate computer response for that action. So if we take a set of training examples, we give it to a supervised learning algorithm, that algorithm creates the model for us, and we don't have to write that code. So that's the idea of how it works. If everything goes well, we can show this model a new hand, and hopefully it's going to come up with the right response and say, oh yeah, that's an open hand. All right, hopefully that's clear. So the software that I'm going to show you, that I'm going to talk about, is called Wekinator. I started building Wekinator when I was a PhD student in 2008. And again, my goal was really to say, you know, this seems like a useful paradigm for people who want to build gestural interactions with music. How can we build a tool that composers can use? What does that look like? Some of you might be familiar with tools like Weka. Lots of you now are probably using tools like SciPy, scikit-learn, right? There's lots of really good general purpose machine learning tools out there. And I started with that kind of approach when I was doing this work. However, there's a few interesting differences that come up when you think about how you might apply this in a creative context, like musical instrument building or music composition. And the first thing that you'll notice is that this training set here probably doesn't exist. So if I want to make a new hand gesture controlled instrument, I can't go on the internet and go to a repository and download the ground truth hand gesture training set, right? That thing doesn't exist, but I can create it, right? I'm perfectly competent at creating hand gestures and demonstrating hand gestures and showing them to the computer, and so I can do that. And so the first thing that Wekinator allows you to do is to create your training set from scratch. Next, if you're using more conventional machine learning environment, you train the algorithm, you get a model, you usually do some kind of empirical testing of that model to find out if it's learned the right thing. There's some problems with that in this context, and I can come back to that later if you guys are interested. But it turns out a really easy thing, a sensible thing to do is not to run empirical tests on this model, but in fact to go to that model, show it new gestures or show it new actions with your sensors and see what it does, right? That's a perfectly valid way of testing that if the person is familiar with what the model should have learned. And then the really powerful part of this is that if the model doesn't do what you want it to do, you can go back and change your training data, right? So if it made a mistake on this example, it said, oh, that's a closed fist, I could go back and add this slanted hand as a training example and then retrain. Or if I said, all right, I'm happy with this model, but it's pretty boring, it just gives me these two classes, maybe I wanted to do something more complicated, I can go back to the data and give it another class, right? So this set of interactions here, you'll see papers, especially in the human-computer interaction research community, describing these kinds of interactions as interactive machine learning, or as human-in-the-loop machine learning, where you're in this tight feedback loop where you're giving training examples, training a model, testing it out, and then changing your training data in order to steer your model in some other direction. So this doesn't really make sense in a lot of music machine learning tasks. If you imagine, you're trying to build a genre classifier, for instance, it may not be that you can fine-tune your model by just giving it more classes of music. That might work. Sometimes it's reasonable. Sometimes what you want to do is just say, hey, I have this whole music catalog. I don't know what kind of music I'm going to have in the future, but I want to build the most appropriate model for this catalog. And then you're kind of stuck with that. You have to do other things like choosing different learning algorithms, choosing different features. But here,
We have a question.
if you have a, yeah, sure, go ahead.
I should probably move closer to the mic, right?
Yeah.
Yeah. So I'm very interested in interactive machine learning that you're talking about. And so when you're having the person train, let's say with an open hand and then the closed fist, how many times do they have to do the open hand?
Yeah, that's a great question.
Is it like
Yes.
10 times, 100 times? Are they sitting there doing it like 500 times?
Yeah. So
Yeah.
clearly, you know, if you a lot of the interactive machine learning research you'll see in outside of human-computer interaction in machine learning theory publications, they assume this ridiculous number of examples that people provide, or a ridiculous number of labels that people provide. Obviously, that's not so helpful in real-world contexts. And so one of the things that I've done in building Wekinator is try to choose and think about algorithms that are going to learn effectively from very small example sets. So what I'm going to do next actually should be helpful. I'm going to show you a demo video, and you'll see in the demo that I'm not giving it, I think in this demo I'm building a classifier where I'm giving it sort of different gestures in front of a webcam. I'm not giving it 100 different examples of me standing in front of the webcam. I'm not even really giving it like 10 different examples in terms of me standing here 10 different times. But what I am doing is I'm continually taking a series of snapshots. So I am extracting features at a rate of, in this next example, I think maybe 10 or 20 times a second. But the examples are also very, very similar to each other. So they're not really adding more data to the algorithm. So I don't think I say this in the demo video, but the classifier that I build is actually using a one nearest neighbor classifier. And this would work pretty well if I only had, say, a dozen snapshots of each different gesture. It might even work okay with fewer than that, but as you'll see, the feature extractor I'm using is pretty bad. So you do need more than one often. But yeah, so with that, let's go to the demo video. And then if you still have questions about that, or you guys want to talk about that, then we can talk about it after the demo. So I'm going to show you two things in the demo. One is building a classifier, and one is building a continuous controller. And the last thing I want to mention before the video is that what's happening here